HC Verma, Wave Motion and Waves on a String, question 15. Here is the setup. A string of length 20 cm is fixed at both ends and kept under a tension of 16 newtons. A short wave pulse is produced near the left end at time t equals 0. Let us watch how this pulse travels, reflects at each fixed end with inversion, and returns to its original shape after one complete round trip. Here is the full question. A string of length 20 cm and linear mass density 0.40 grams per centimeter is fixed at both ends and kept under a tension of 16 newtons. A wave pulse is produced at t equals 0 near one end. Part A. When will the string have the same shape again? Part B. Sketch the shape of the string at a time half of that found in Part A. The key concept here is pulse propagation on a string fixed at both ends. The wave speed v equals the square root of tension t divided by linear mass density mu. When a pulse hits a fixed end, it reflects with inversion, that is, it flips upside down. After two reflections, one at each fixed end, the pulse has been inverted twice, so it returns to its original upright shape. The total distance for one such round trip is 2L, that is, twice the string length. So the time to regain the original shape is 2L divided by wave speed v. Part A. First, let us find the wave speed. Linear mass density mu is 0.40 grams per centimeter, which equals 0.04 kilograms per meter. Wave speed v equals the square root of tension t over mu, which is the square root of 16 over 0.04. That gives the square root of 400, which equals 20 meters per second. Now, the string length L is 20 centimeters, that is 0.2 meters. For the pulse to return to its original shape and position, it must complete one full round trip of distance to L. Time equals to L over v, which is 2 times 0.2 divided by 20, giving 0.02 seconds. Part B. At half the time, that is, at t equals 0.01 seconds, the pulse has travelled a distance of v times t, which is 20 times 0.01, that is, 0.2 meters or 20 centimeters. This equals exactly the string length L. So the pulse has reached the far fixed end and has just reflected once. Since reflection at a fixed end inverts the pulse, the string has an inverted pulse, pointing downward, located near the far right end. Let me draw this shape. The correct answers. Part A. The string regains its original shape after 0.02 seconds. Part B. At t equals 0.01 seconds, the pulse is inverted and located near the far fixed end. Here are some important tips. Tip 1. Always convert units carefully. Linear mass density given in grams per centimeter must be converted to kilograms per meter for C calculations. Tip 2. At a fixed end, the reflected pulse is always inverted. At a free end, it reflects without inversion. Tip 3. For the pulse to return to its exact original shape and position, count how many reflections restore the original orientation. Two fixed end reflections mean one full round trip of 2L. Tip 4. The wave speed on a string depends only on tension and linear mass density, not on the pulse shape or amplitude. Like and subscribe for more HC Verma solutions at MAGPIEHUB. See you in the next video.